Hello everyone, my name is Rachel. I'm an engineer on the Multi-Cluster Gateway Controller project. Today I'm going to be walking you through how to install the Kuadrant operator via OCM add-on, as well as how to configure some rate limiting policies. This is a follow-on of the demo called Multi-Gateway Controller on Open Cluster Management. The link to that video is in the description. To give an overview on OCM, it stands for Open Cluster Management. It is a hub and spoke cluster architecture. The hub cluster being the control plane in the system and the spoke clusters being controlled by the hub cluster. In OCM, there's what's known as add-ons. Add-ons are extensions in the OCM system that are used to work with multiple clusters. Add-ons are made up of two components. You have the add-on manager, which is a Kubernetes controller located in the hub cluster. This is used to generate and apply add-on manifests to the spoke clusters via what's known as the manifest work API. You also have the add-on agent. These are the resources that are running on the spoke clusters. So in our example, this is going to be the operator group, namespace, and subscription. So you can see here we have our hub cluster and our spoke cluster. We have our add-on manager, which is located in the gateway controller namespace. This then watches our managed cluster add-on and our cluster management add-on, as well as then creating the manifest work CR, which is what I spoke about earlier, which is our Kuadrant add-on. This then creates the namespace, Kuadrant systems, our operator group and subscription for OLM, which then creates our Quotient operator, our limiter operator, and our authorino operator. So that's an overview of the architecture of the hub and spoke cluster. I'm going to go into a little bit more detail on the managed cluster add-on as well as the cluster management add-on to see what these will look like. So after watching the previous demo, you will know that we have two clusters currently. We have a hub cluster that's also our spoke cluster, so that shows if you have a single cluster, and we also have a second spoke cluster, which is just a spoke cluster if you are migrating from a single to a multi-cluster. So what we're going to look at now is what I showed in the architectural diagram, which is the managed cluster add-on. This is called the Quadrant add-on, and it's dictating where we want the add-on to go. So we want it to go to the kind MGC workload 1 namespace. So that is the name of our second spoke cluster. We also mentioned the cluster management add-on. This is used to tell the user what add-ons are available for them to install. And our one is called Quadrant operator, and the name of it is Quadrant add-on. So the description is Quadrant operator. Okay, so what I've already gone ahead and done is applied these to the clusters. So the add-on manager is working in the background and is applying these to the clusters via the manifest work API and creating the subscription, the operator group, and the namespace. So you can see here the Quadrant system namespace was created. So if I do a kubectl get pods, you'll be able to see that we have the Quadrant operator is installed and running, as well as the authorino and the limiter. So what I'm going to show you now is the workload that we currently have running that was implemented in the previous demo, that it's currently running without any rate limit policy. So if I do a quick curl command on this, you'll be able to see that there should be no issues and we should get 200s across the board. So what I'm going to show you now is the rate limit policy that we're going to apply. So this is going to hook up into limiter, which is a operator as part of Quadrant. So looking at this rate limit policy, what are we actually doing? We are using the target ref, so this is dictating where we want the rate limit policy to go onto. So this is going to be going against our HTTP route, which is attached to our gateway. You can then see the limits. So the limits are essentially what configuration we want the rate limits to have themselves. So you can see that's going to have that we're only allowing a max value of 3, so that's essentially 3 requests to the root every 10 seconds. So we'll see that then once we apply the rate limit, we'll do the same curl command again and we'll see the change from all 200s to the new change. To get more information on limiter, please see the video linked below. In the description, it goes into much more detail, the ins and outs of the rate limit policy and how limiter works. So now that we've applied the rate limit policy, we should now see when we do a curl command again that we're not going to get the all 200s like we were before. We're going to get 3 200s and the rest non-200 status codes. So if we do a while true, we can see that now. This is the first spoke cluster, and we'll see the same thing in the second spoke cluster. And we do. So there's two types of ways to have storage for Eliminador. You can have the local storage that we just seen, or you could have Redis. So what I'm going to show you now is how to use shared Redis. So what is different to the shared Redis storage versus the local storage on the cluster, like you previously saw, is that with the local storage, as you saw in the previous clip, that when you hit the limit on one cluster, you are not hitting the same limit on a different cluster. A new rate limit policy, even though it's the same when we look at it, it's not shared across all clusters. So the other option, where you have the same rate limit policy across the board, meaning that when you hit the limit on one cluster, you're also still hitting the same limit on a different cluster, is via what's known as a shared Redis. So what I'm going to show you now is how to implement that. So all you need to essentially do with the difference between the local storage and the shared storage is you make a change into the Eliminador CR, and you essentially just specify here the Redis that you want to target. So our Redis is in our hub cluster, but your Redis can be anywhere, and you give it the secret with the information that it needs. So what I've gone ahead and done already is I've gone and applied these rate limit policies you see here. So it's hitting our host that we saw earlier, so rachel.hcpapps.net, and it's having, so we can have a max value of 5 in 10 seconds. You can see it's pointing at our HTTP route that we created earlier called my route. So if I go ahead and use this while true, which is just going to loop through and ping every second, here we can see we're getting SAS 200, and we should see 5 SAS 200 codes, and then it should kick into a non-SAS 200 code, so we're getting 429s. So if I let this run for a second, we should go back into 200s again, and I'm going to, so we're going to get into the 429 here, and I'm going to go to my other cluster, and you can see that we're still getting 429. So we're going to get 200s for a while, and go back into 429. So what I was trying to do is it's going to try to split the 200 across both clusters. This is getting 429, and same with this cluster. So you can see it's using the shared Redis across both clusters, and the Redis is actually located in our hub cluster, but the Redis can be the Redis cluster can be created in any cluster. The following walkthrough that I just showed you will be available for you guys to do yourselves. The previous demo will also be available on YouTube and is linked below, so please check that out before you move on to this one. It gives a lot of context on OCM and the gateway that's linked to the HTTP route. Any questions that you guys have, please make sure you leave them below in the comment section. We'll get back to you as soon as we can. Thank you very much.